A viral clip recently exploded across social media, claiming to show a close-up of interstellar comet 3I Atlas drifting through space. A dim, moving point of light that looked almost alive, surreal, poetic, and utterly mysterious. The clip spread fast. Thousands of shares, excited comments, and automatic AI tools that began labeling the footage as Atlas, which amplified the claim. But within hours, the professional astronomy community sounded the alarm. The video lacked every basic trait astronomers expect from real telescope footage. No background star field, no image noise, no long exposure streaks, and crucially, no cometary coma or tail. Instead of the grainy, jittery images typical of deep sky captures, the clip showed unnervingly smooth motion and unnaturally crisp detail. The hallmarks of an artificial creation, not an observational record. Lead stories and other fact-checkers jumped in, running reverse image searches and metadata checks. Their trail led nowhere in the scientific databases. No matching frames in NASA, ESA, IAU, or any professional observatory archives. No notice from Hubble, JWST, or ground facilities tracking 3I Atlas. In short, the clip did not originate from the astronomical community. To get a second opinion, investigators asked an expert in microscopic imaging to examine the footage. Professor Jack Gilbert of the Scripps Institution of Oceanography, a biologist experienced in identifying microscopic life, reached a startling conclusion. The moving subject in the clip matched the look and motion of a microscopic, single-celled freshwater organism seen under a microscope, not a comet in interstellar space. So what really happened? The answer is a mix of social media dynamics and modern image tools. An evocative video, combined with automatic content tagging AI and a hungry online audience, created a viral feedback loop. Speculation fed the algorithm. The algorithm fed speculation, and credibility was assumed without verification. The clip's aesthetics, smooth motion, lack of background stars, and unnatural clarity match what advanced AI generators and microscopic time-lapse footage can produce, not what long-exposure astrophotography yields. Real comet images include background star fields, detector noise, diffraction spikes, and consistent spectral signatures. None of those are present in the viral piece. This incident is a cautionary tale. It shows how easily compelling visuals can hijack public attention, and how vital verification is before accepting sensational claims about space. It also highlights an uneasy new reality. AI can generate images so convincing that non-experts will mistake them for genuine astronomical discoveries, while automated labels and social sharing make the myth spread with near-instant speed. The scientific process, cross-checks, metadata, independent confirmation by observatories, remains the guardrail. Until professional telescopes or space agencies release verifiable data showing a direct observation of 3I Atlas, such viral clips must be treated as unverified media, not evidence. In this special episode, we traced the viral clip from post to provenance, consulted astronomers and image experts, and found no observational basis for the claim that the footage shows 3I Atlas. The real lesson isn't that space frauds are new. It's that in the age of AI and instant virality, critical thinking and source checking matter more than ever. If you want follow-ups, I'll keep tracking official observatory releases, and we'll break down any new verified images of 3I Atlas as they arrive. This revelation completely shocked the online community. What everyone thought was an image of a mysterious comet drifting through the depths of the universe turned out to be something far smaller. A microscopic creature swimming in a single drop of water. The worm's slender body moves rhythmically, powered by thousands of tiny cilia that create gentle wave-like motions, almost as if it's dancing. Under the right lighting, those rippling movements shimmer like a miniature galaxy, forming a breathtaking optical illusion that can easily deceive even a trained eye. When the footage was cropped, darkened, and stripped of its original context, it perfectly resembled a comet gliding through the cosmos. In truth, it was just a clip from an educational biology video used for teaching about single-celled organisms. Yet once falsely labeled as an interstellar image, it spread like wildfire across social media, gathering millions of views and being hailed as proof of extraterrestrial life within mere hours. This episode perfectly illustrates the immense power of digital media and artificial intelligence. With just a few visual tweaks, an ordinary classroom experiment transformed into a cosmic discovery that captivated the entire world. It's also a humbling reminder that sometimes the wonders we believe come from the farthest reaches of the universe may actually exist right in front of us, in something as small and overlooked as a drop of water. Ironically, the real Comet 3I Atlas doesn't need fake videos to be fascinating. It already stands as one of the most remarkable astronomical discoveries of the decade. Detected by the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Hawaii on July 1st, it became only the third known interstellar object ever observed by humanity, after Oumuamua in 2017 and Tuai Borisov in 2019. Its incredible velocity and open, hyperbolic orbit confirmed its origin from beyond our solar system, ensuring it would never return once it passes by. Scientists describe 3I Atlas as a natural messenger from a distant star system, a fragment that may have formed billions of years ago around another sun and been ejected during that system's chaotic youth. By passing close to Earth, 3I Atlas has given researchers a rare window into material older than our own planet. Observations from the Gemini South Telescope, operated by NORLAB and the European Southern Observatory, ESO, revealed a faint tail and a delicate halo of gas, unmistakable indicators of a comet whose icy body vaporizes under sunlight. But what truly makes 3I Atlas extraordinary is its chemistry. Spectroscopic analysis shows an unusual ratio of carbon monoxide to water, hinting that this interstellar visitor carries a unique chemical fingerprint, a clue to the diverse conditions that shaped planetary systems across the galaxy. The ice within Comet 3I Atlas is markedly distinct from that of other comets in our solar system, suggesting it originated in an environment far colder, perhaps on the outer fringes of an ancient nebula, where the light of its parent star barely reached. Each interstellar object like 3I Atlas acts as a priceless relic of cosmic history, a fragment that helps scientists piece together the grand puzzle of planetary origins and stellar evolution. By comparing its chemical makeup with that of local comets, astronomers gain deeper insight into the diversity of materials and the formation, conditions of other planetary systems, ranging from primordial ices to complex, organic molecules that may hold the earliest clues to life itself. Ironically, the viral video surrounding 3I Atlas, though false, ended up masking the comet's true scientific importance. While it bore no connection to the real celestial object, it did reveal a fascinating coincidence of natural patterns. At vastly different scales, the motion of life and the movement of cosmic matter can mirror one another. Under a microscope, the gentle undulation of a copepod's body produces visual rhythms strikingly similar, at least morphologically, to the shifting dust and plasma trails that swirl behind a comet in space. Despite the physical differences spanning orders of magnitude, both follow universal principles of fluid mechanics and light scattering. Such resemblance reminds us of nature's recurring symmetry. What happens in the microcosm often echoes in the macrocosm. Yet science does not rest on visual likeness or viral allure. It stands on evidence. It requires precision, repeatability, and peer review. A captivating but anonymous video can never replace verified data. The true beauty of 3i Atlas lies not in social media speculation, but in the cosmic story it tells. A shard of ancient matter traveling through interstellar space, carrying within it the secrets of planetary birth, solar system formation, and the evolution of galactic matter. This entire episode also highlights a pressing issue of our digital age. Misinformation travels faster than truth. On platforms designed to reward engagement and novelty, falsehoods can ignite before experts have a chance to verify the facts. Even AI-generated summaries, when stripped of source control, can unintentionally amplify bias. In such a landscape, scientific transparency becomes more vital than ever. Reputable agencies such as NASA, ESA, NOIR Lab, and independent fact-checkers like Lead Stories and Reuters uphold these standards by publishing open data, observational reports, optical spectra, and orbital parameters accessible for all to review. For astronomy enthusiasts, the most valuable habit is skepticism with curiosity. Always verify the origin of a claim before sharing it. If a video lacks backing from an observatory, a research institution, or a credible space agency, pause and cross-check. In an era when information travels at nearly the speed of light, thoughtful skepticism isn't cynicism, it's scientific wisdom. Meanwhile, Comet 3i Atlas continues its silent voyage across the solar system, tracing a path that began millions of years and light years away. In the months ahead, NASA's Vera C. Rubin Observatory and the SphereX mission will target it for close observation, gathering intricate data on its brightness, structure, and chemical spectrum. These findings may finally answer whether 3i Atlas behaves like a conventional comet or whether it is something far rarer, a frozen fragment of interstellar rock drifting endlessly between the stars. Through spectral analysis, scientists hope to decode its formation story, identifying the signatures of ice, carbon, and complex organic compounds that could illuminate the origins of life itself. These phenomena have only deepened the mystery surrounding 3i Atlas, transforming it from a mere astronomical curiosity into one of the most fascinating cosmic enigmas of our time. The data collected will not only expand our understanding of this particular object, but also provide critical insight into how distant star systems are born, evolve, and die, knowledge that may one day guide humanity in identifying habitable worlds beyond Earth. Over the next decade, astronomers predict the detection of dozens more interstellar visitors streaking through our solar system, paving the way for a new scientific discipline: interstellar planetology, the study of material originating from other stars. Each of these celestial wanderers, including 3i Atlas, acts as a cosmic messenger carrying secrets about planetary formation, stellar chemistry, and perhaps even traces of ancient, unfamiliar life forms. Recent findings from the James Webb Space Telescope, JWST, have only added to the intrigue. Spectroscopic data revealed that the outer shell of 3i Atlas has been drastically altered by billions of years of exposure to cosmic radiation, forming a hardened layer of carbon dioxide several tens of meters thick, a geological scar from its long journey through interstellar space. Even more astonishing was the detection of an unusually high CO2 to H2O ratio, suggesting that 3i Atlas originated in an unimaginably cold region, possibly on the outermost edge of a primordial nebula where starlight could barely reach. Polarization data further unveiled a rare optical feature, an unusually deep and narrow antipodal branch, a scattering phenomenon never before seen in any known comet. These anomalies have sparked heated debate within the scientific community. While a small number of theorists speculate that 3I Atlas could even be a fragment of extraterrestrial technology, the majority of researchers maintain that it remains a natural, though highly peculiar interstellar object. Supporting this, a recent NASA analysis revealed that as the object neared the sun, it began emitting a faint blue luminescence, a possible sign that organic compounds or carbon monoxide trapped within its crust were becoming active under solar radiation. This strange awakening hints that parts of its structure may still be reactive, suggesting that the comet carries within it dynamic chemical processes frozen in time for billions of years. In essence, 3I Atlas is rewriting what we know about interstellar chemistry. It is both a relic and a revelation, an emissary from beyond our solar cradle, whispering stories of creation, transformation, and the infinite complexity of the cosmos. Not only do these discoveries make 3I Atlas one of the most extraordinary interstellar visitors ever observed, but they also open the door to a new era of cosmic exploration, as more such travelers are expected to be discovered in the coming decade. As 3I Atlas continues its silent voyage through the solar system, the James Webb Space Telescope, JWST, has unveiled fresh and fascinating details. Infrared data revealed that the object's surface has been eroded by billions of years of exposure to cosmic radiation, leaving behind a dense crust of carbon dioxide, a strong indication that it once existed in an unimaginably cold region, possibly on the far edge of a distant star system where light from its parent star barely reached. Even more striking is the discovery of an unusually high CO2 to H2O ratio, unlike anything recorded in comets within our solar system. This suggests that 3I Atlas might be carrying ancient, untouched material from a part of the galaxy that humanity has never explored before. Adding to the mystery, recent polarization data revealed a rare optical phenomenon called deep and narrow antipodal arms, a distinctive light-scattering pattern that has never been clearly documented in any known comet. Some astrophysicists speculate that this anomaly may be caused by an exotic crystal-like surface structure, or even a new unidentified form of matter. Others go further, proposing that the object could be the fragment of a long-destroyed planet, a remnant from a star system that once nurtured complex organic compounds, or perhaps the earliest traces of life itself. The strangeness of 3I Atlas grew even more apparent when several telescopes detected the object emitting a faint green glow as it approached the sun, as though something within it were awakening. NASA attributes this glow to the evaporation of carbon monoxide and organic materials, but a few independent researchers have suggested something far more intriguing, a self-healing chemical reaction, a process never before observed in natural comets, that might allow certain molecular structures to reactivate under heat. Adding to the enigma, astronomers have reported an unverified radio signal near 1,420 MHz, the hydrogen line frequency often used in the search for extraterrestrial intelligence. The signal was detected at the same time that 3I Atlas passed through a monitored observation field. Although no concrete evidence links the signal to the comet, its timing has sparked widespread debate across the scientific community. Experts predict that in the years ahead, advanced observatories such as NASA's SphereX mission and the Vera Rubin Observatory will uncover dozens of new interstellar objects, each one a messenger from beyond our solar system, carrying fragments of alien chemistry and cosmic history. Objects like 3I Atlas remind us that these icy wanderers are not merely frozen rocks drifting through space, but pieces of a vast cosmic puzzle, clues to the origins, evolution, and perhaps even life itself within the Milky Way. If you'd like to follow this story as it unfolds, make sure to subscribe and turn on notifications for this channel. I'll continue posting updates as new data emerges, especially after perigee, When we'll get a clearer look at 3I Atlas following its close encounter with the sun. And I'd love to hear your thoughts. Will it survive perigee intact? Or are we about to witness its spectacular fragmentation? Drop your theories in the comments below. I read every one of them, and who knows, your idea might be the spark that leads to the next great cosmic discovery.